Welcome to GUL Mathematics and AKD Physics. In this interaction, my main intention is to find the distance between two objects which are in a three-dimensional space. So let us consider object A and object B having coordinate x1, y1, z1 and x2, y2, z2 respectively in a three-dimensional space. And let D be the distance in between A and B. I have to find that D. Okay, so to do that, first of all, draw a perpendicular A on xy plane, on this plane. Then what is the coordinate of A prime? What is the coordinate of A prime? That will become your x1, y1 and 0. Since this is on xy plane, so your z coordinate is 0, right? And again similarly draw another perpendicular from B on xy plane. Then what is your coordinate of B prime? No doubt that will become your x2, y2 and 0. My z coordinate is 0 here because I am on this plane, on xy plane. Okay, your next work is draw another perpendicular from this A on this line, on your B prime line. So draw another perpendicular on this line and name it as C. Okay, so and this is your A prime B. This one is your A prime B. See here in this picture, in this you can observe the parallelogram A prime, B prime, C. In this parallelogram, A prime, B prime and AC both are parallel and equal. So from the geometrical point of view, I can write A prime, B prime is equal to your AC. And you know what is the coordinate of A prime? What is A prime? A prime is your x1, y1, z 0 and B prime having coordinate x2, y2, 0. So the distance between A prime, B prime, we know from our two-dimensional space. The distance between 2 points having coordinate x1, y1 and x2, y2. So that how much is that distance? So that distance should be you according to your formula of distance formula of two-dimensional, that will become your x2 minus x1 square plus y2 minus y1 square root. Okay, and now find this BC, and since BC is the displacement along your z axis, so only z coordinate changes here. This line is parallel to your z axis, so only the changes in z direction. And you can write this point, this C having coordinate your x2, y2 and z1. Okay, so how much is your BC? BC is your z2 minus z1. Why I am calculating all this? Because my target is to find this AB, and no doubt this ACB is a right angle triangle because I am drawing a perpendicular from A to C. So no doubt in my right angle triangle ACB, I can write as AB square equal to your AC square plus BC square. And now I already find how much is AC and how much is BC. So from triangle formula, so from you can denote this as modulus, since distance is a positive quantity. So your AB square becomes your x2 minus x1 square plus y2 minus y1 square plus your z2 minus z1 square. This is your AB square. So how much is your AB? I mean D. I mean distance between the two objects A and B, that is your D is how much? This is your x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. And square root of all this. Okay, so I am getting the distance between two objects having coordinate x1, y1, z1. This is the distance formula between any two arbitrary points having coordinates a x1 y1 z1 and v x2 y2 z2, right? Okay, so I am find the distance formula between two objects having coordinate x1 y1 z1 and x2 y2 z2. The next one is, suppose a point P in your three-dimensional space is here. I have to find the distance of the point from your origin. So no doubt this is a special case of your distance between any two points. Okay, so here you just take this as x1 y1 z1 and x2 y2 z2. Then apply this formula. So you will get, so what you will get? That means this distance d, I mean OP. So OP becomes how much? X minus 0 square plus y minus 0 square plus z minus 0 square root over. So this becomes your x square plus y square plus z square square root. So this is the distance of the point P x y z from the origin O, that is 0 0 0, right? So this is the formula of distance of any point P x y z from the origin. Then the another important thing is, suppose you have a point in your three-dimensional space. Suppose you have a point in your three-dimensional space having coordinate x, y, z, and find the distance of this point from a axis. Suppose I have to calculate the distance of this point from your x-axis, and draw a perpendicular from this point on x-axis and let it be m. Then what is the coordinate of m? No doubt, since I am on x-axis, so my y coordinate and z coordinate both are become 0 0. So apply the distance formula and got the result. That means PM is how much? This will becomes y square plus z square root over. See the logic. Since I am calculating the distance of the point P from the x-axis, x is vanishes here. Okay. So this is the distance of the point from your distance of the point from x-axis. So in the similar fashion, I can write the distance of any point, from y-axis. So since I am considering y-axis, just vanish y coordinate. So that will become, you can write that as PL. You can write it as PL. So how much is your PL? This will becomes your x square, just vanish z coordinate, x square plus z square root over. And if you will find the distance of the point from your z-axis, distance of any point from z-axis, then how much? You can denote it as PN, and since I am calculating from z axis, just one is your z coordinate, then that becomes x square plus y square root over. So this is the entire scenario of finding distance in between any two point, distance of a point from the origin, and distance of a point from x axis, yeah, y axis, yeah, z axis. Okay, and after this I will go with certain problems on this, and in my coming lecture I will go through direction cosines and direction ratios. Okay, so thank you. I hope you enjoy this interaction, and again thank you for watching.